So this is, what we're doing today is just a skill. It's kind of like, and it is related to, like factoring, or like when you learn how to complete the square. And when you did that, you probably did talk about how completing the square of a quadratic is finding the vertex. Like you probably did relate it that way, but completing the square is a skill by itself, right? You can just learn how to do that skill without understanding why or what it's doing or what its purpose serves. Kind of, we're doing some of that kind of today. Like we're going to learn two important new processes, methods, and we'll talk a little bit about what they're doing, but really you need to just learn how to do them. Okay, so you're just learning this skill, and then on Wednesday we'll take a look at more of an application and like how it's going to serve a purpose for us in this course, in this unit. Does that make sense? Okay, so first thing, a few little definitions. I don't know, the textbook doesn't always present it exactly this way, but I think it's helpful to talk. It does talk about the dividend, the divisor, the quotient, and the remainder. So those are certainly words that you should know. And some of these you'll remember from a long time ago when you learned how to divide, like with long division back in elementary school, grade 4, grade 5, whenever you start learning about long division. Some of what we do today is going to look very similar to that. Okay, it's the same kind of idea. So the dividend is what you're dividing into. That's the function that you start with. Okay, the divisor is what you're dividing into the dividend. So the dividend divided by the divisor, and then the result that you get we call the quotient. And if there's a remainder, which there sometimes is, then we call that the remainder. And each one of these things could kind of be considered a function in and of itself. So we can use these as a standard to talk about each one of those. So f at x would be the function that we're starting with, d at x the divisor, q at x the quotient, r at x the remainder. So we have our division statement. We're going to talk about this again later. It'll make a bit more sense later. But when we finish one of these questions, we always write a division statement, and it'll look something like this. F at x equals the thing you're dividing by. We usually write it in this order. Times the quotient plus the remainder. And again, this will make a little bit more sense after we've done an example. But the first method we're going to look at looks like this. So you're dividing, and you'll recognize this a little bit. You're dividing d at x into f at x. There's your long division thing from a long time ago. You end up with q at x, your answer up there, and dot, 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 down here somewhere you end up with r at x. Does that make sense? So this is why it's nice to kind of have these little short forms so we can visualize what each part goes with what. And those words are worth it's worth thinking about this, because there's a few questions that are worded in such a way, like in the homework today and later this week, that if you don't fully think about the relationship between the quotient and the dividend and the divisor and how they're all related and the remainder, you don't really think about how they're related, which to some extent the division statement can give us, then very simple questions will become very difficult. There's a few questions that are very simple, but people go through all kinds of crazy ways of solving them because they don't really think about that relationship, about how all of these things here are related. Okay, so to give you an example that you would be able to kind of think about, what if I was dividing 5 into, nope, not 10. What's going on? 5 into 11. Okay, so 11 is the function. It's the dividend. It's the thing you're dividing into. 5 is the divisor. You're dividing 5 into 11. Okay, what's your result going to be? How many full times does 2 go into 11? Twice. And then dot, dot, dot. We don't really talk about remainders anymore when we divide. Like now when we divide, we go to a decimal, right? We get whatever part is left and we divide it up 2. But this is how you thought about it a long time ago. And interestingly, if any of you have pursued math in university, you go back into talking about remainders and that kind of thing. It's called modular math. Very, very powerful stuff. Big in computer science and other areas. And you end up talking about remainders again. Anyway, so then there's your remainder, right? Does that make sense? Pretty straightforward, pretty clear. And then here's something that's interesting. This will come up a little bit later. What if I divide it directly into 10, what will my remainder be? 0. Turns out that's very important for what we're doing. Okay, so we will revisit this, but you do need to kind of know this today, is if you get a remainder that's 0, what does that tell us? It tells us 5 divides evenly into 10, or it tells us that the divisor divides evenly into the dividend. But more importantly, it tells us that it's a factor of the dividend. It divides evenly means it is a factor. If you think about that, 5 is a factor of 10, right? You understand that. You know what factors of numbers are. If I said write out some factors of 24, you could do that. The numbers that divide evenly into it. 5 is not a factor of 11, and we got a remainder. If you have a remainder that's not 0, it's not a factor. Doesn't that make sense when you think about numbers? But if you have a remainder that is 0, it's going to be a factor. That makes sense. Well, that is true of polynomials as well. It turns out that's a very, very important, very useful thing that we'll take a real advantage of on Wednesday when we come back and revisit this again. So keep that in mind. And some of the questions ask you to do the division and then state whether or not it's a factor. That's a question asking about the remainder, right? So keep that in mind. Okay, any questions before we move on? There's 2 methods that we're going to use to do this polynomial division, and you need to know both. We'll probably have a quiz on this on Friday of this week, and the quiz will say to do the following division with long division, do the following division with synthetic, which is the next one, which we're going to learn next. Okay, so you absolutely need to know how to do both. All right, let's take a look at the first one. Unless there are any questions, we'll get started. So first we're going to set it up. I'm dividing x plus 3 into x cubed plus 4x squared plus 6x plus 5. See, now it doesn't look as, as nice and neat as those ones that involve numbers. Now it's hard to, it's probably hard the first time you're seeing this to understand, I don't really know what we're doing. Like dividing a polynomial into a polynomial doesn't really make sense. It goes in evenly 3 times and there's a remainder of 7. Like what is this talking about? Doesn't make sense to me. Okay, and it is a little bit trickier, but again, remember this is just a skill. So really what you are doing is like powering through this, figuring out how to accomplish this skill, and then it will make more sense later on in the unit as we continue to go. Okay, everybody good? So what we're going to start with is we take a look at this leading term and we sort of ask how many times does it go into that first term. Okay, so that's what we're starting with. And how many times does it go in? It goes in x squared times. What does that mean? But think about it this way. You can always turn a division question, turn it around back into a multiplication question. X squared times x gives you x cubed. Right? Doesn't that make sense? What do I multiply? So what we're asking is, what do I multiply this by to give me this? That's what division is. Think about it with numbers. 12 divided by 3. What number times 3 gives me 12? It's the same thing, right? So what expression multiplied by x gives me x cubed? It's x squared. That is what that is division. And you've done this with common factoring and stuff. He's not that far off, but it looks weird to you the first time you see it like this. Okay? And again, this would be kind of familiar. So then we do take this number and we multiply by x, and it gives us x cubed, and those have to match. Okay? And then the next step is I do x squared times this, which gives me plus 3x squared. What do you think I do next? Anybody have a guess? Anybody who hasn't seen this before? You remember from like grade 4 or 5 when you started doing long division what you do at this next step? What's your gut tell you? Subtract. So x cubed minus x cubed gives you 0, and that has to happen, folks. So that's when you set it up like you make that happen. If that doesn't happen, you've done something wrong. 4x squared minus 3x squared is just positive 1x squared, right? So you could show that. We don't always, but that is what you're doing, is subtracting. Bring down this 6x. That's probably kind of familiar as well. And repeat the process until we're finished. That's all that happens next, right? So that was one, what we call iteration of the process, and then we continue doing it again and again. So now I do x into x squared. How many times does it go in? X times. So that x times x gives me back x squared. And x times 3 gives me 3x. Subtract. X squared minus x squared gives you 0. Yeah, that's supposed to happen. 6x minus 3x is 3x. Bring down the 5. Repeat. X goes into 3x how many times? 3. So that 3 times x gives me 3x. 3 times 3 gives me 9. Subtract. 3x minus 3x is 0. 5 minus 9 is negative 4. Careful of those negatives. And we're done, because I can't divide x into negative 4x. Can't divide any further. We're done. And if you line everything up properly, once it starts clicking, if you line everything up properly, you get like to the end. You're done, right? You get an expression that sort of matches the one below it. You get to the constant, in other words, and you're done. How's everybody feel about that? Very good. Negative 4 is our remainder. So then I could ask you, is x plus 3 a factor of the original function f at x? No, it is not. Right. But then some people are saying, okay, no, it's not, but I don't even know what that means. That's okay. You will later on. Like eventually, it will be very obvious on Wednesday when we revisit this, what it means that something's a factor. We got to add a step. But we need to learn this process first before we can start talking about that. So the answer to that question is no, it's not a remainder. What does that mean? You can think about, no, it's not a factor. You can think about factors of numbers. Like it is the same thing. I can break 24 up into 6 times 4, not plus something. 11 is 5 times 2 plus 1. 24 is 6 times 4, because those are both factors, right? It is related to that. And it has to do with factoring, and it has to do with all these things, but we'll get to it. Okay, so our division statement is f at x, the original function, equals, you don't have to write this every time, q at x plus r at x. So we just write f at x, or if you start with a different thing, you would write that. Like if the question was g at x, you'd write g at x equals, right? But f at x equals x plus 3 times x squared plus x plus 3 minus 4. Division statement. Always end with that. And the next step is think about what that means. It means if I expand those brackets and then collect like terms at the very end with the minus 4, I should get back that original function. So we've rewritten this in a different way, just like when you learn how to factor, just like when you learn how to complete the square. We're rewriting the same expression but in a different way, which will eventually become convenient. That's where this is going. Any questions? See one more? Let's try it one more time. Think about that. Okay. So let's get this set up. X minus 2 divides into 2x to the 4th plus 5x cubed. Now I have to be careful here. What is different about this one? I kind of made it obvious the way that I wrote this out. Okay. There's no x squared term. And when that happens, think about if you wrote the number 101. There's a 0 in the tens column, inherently in the way we write numbers. But that's not the case when we write polynomials. So you've got to add that back in order for this process to work. So whenever, no matter what kind of division you're doing, you always have to make sure you've got every term from the highest degree to the constant. So if you have to add zeros to make that work, then that's what you do. That make sense? And as long as we do that, then it's the same process and it'll work out the same way. So x goes into 2x to the 4. How many times? Mason? Good. 2x cubed. So that when I do 2x cubed times x, I get 2x to the 4th. There's that little check every time that you do this process, that those match so that you get 0. And the other thing that doesn't come up in these examples but will come up in the homework is you make sure that you line up terms with the same degree. So right now we're dividing binomials, but if it was a trinomial, it's a little bit different, but I want you to think that through when it comes up. And all you have to do is make sure these match, and then it'll work out, basically. Okay, so let's keep going. So 2x cubed times negative 2x is negative 4x cubed. Subtract. 5 minus negative 4 is 9x cubed. Okay, I'm going to let you try the next step. Okay, did it look like that? Is that right? Negative 18? Okay, keep going. It's very likely that at least some of you, probably most, half or 3/4, will forget the first time or the second time or the third time that it comes up to put in the 0x squared. Because you just start writing and it only comes up once in a while, so you just forget. But then you get to that stage where you would be using it, and all of a sudden your terms aren't lined up, and you're like, what's going on here? I'm like subtracting x squared from x or something. Like something's not working, right? And so that's hopefully will jog your memory and go, oh yeah, I forgot the 0x squared. So once you get that strange feeling like something's not matching or working, that's what's going on. Okay, keep that in mind. And believe it or not, your integer skills have to come into play here. Negative 7 minus negative 36, negative 7 plus 36, so that's positive 29x. Okay, bring down the 10. And so it's going to go in plus 29 times. So I'm at the constant, so this is going to be my last time going through this. I get 29x, and 29 times negative 2 is negative 58. 10 minus negative 58 is positive 68. Big remainder. So what does that tell us that there's a remainder? That x minus 2 is not a factor of f at x. 2x to the 4th plus 5x cubed minus 7x plus 10, that original function, right? So it's not a factor of that. And some people ask, what does it even mean for x minus 2 to divide into 68? Like, don't worry about that. That's not really useful to worry about that necessarily, at least at this stage. You know, we got to the end of the process. There's a remainder. Therefore, f at x equals, write our divisor statement, 2x cubed plus 9x squared plus 18x plus 29 plus 68. And then again, if you expanded that, you should get back the original function. Any questions? No? You sure? So that's long division. That's one of the two methods. Going once, going twice. So now we're going to learn synthetic division. And then you get to decide which one you like best. And I have a prediction about which one you're going to like best. But like I said, you need to know both. On a quiz, on a test, on the final exam, a question might say, complete the following using long division. Or it might say, complete the following using synthetic. Or it might just say divide, in which case you would get to choose your favorite, right? But it could also tell you which one to use, so you got to know both. But yes, absolutely, if it doesn't prescribe which method to use, you pick your favorite. Everybody picks the same favorite. I've never had anybody pick different. Actually, that's not true. You get a couple people maybe who do it the other way. Okay, so first we have to set this up. Now, if you've taken this course before, I probably do this a little bit different than the way you've seen it before, because there's not one way of doing this. So if you already know how to do this, you can use your method. That's fine. Keep that in mind. Okay? And the way we write these things sometimes is a little bit different. So we start sort of the same way, but notice, I don't know, this is a really minor thing, but that line straight's not curved. And all I do is I write out the coefficients. You could write out the whole thing, but we tend not to. Again, that's just how different people are different. So we write out the coefficients of each of those terms. Everybody got that okay? So the problem with this method is, especially at first, there's no meaning behind what we do. Like, there's no why. There is a why, but you won't see it. So you just have to memorize the steps, literally. It's like you're a robot just doing it without any understanding what you're doing. That's okay. And then once you've done it a few times, you kind of look back at what's happening, you can figure it out. But you got to just remember, okay? So step one is bring that first thing down. I'm going to just change my color for that, but bring this first thing down and turn it into a 1. Then you take 2 times 1 and you put it there. So 2 times 1 is 2. And then you subtract. Negative 5 minus 2 is negative 7. And then you multiply 2 times negative 7, which is negative 14, and you put it here. And then you subtract. So negative 1 minus negative 14 is positive 13. And then you multiply by 2 and you get 26. And we're at the end. 12 minus 26 is negative 14. And obviously we're done and it's really obvious what the answer is, right? Everybody? Right? Everybody Understands exactly what we've done here. It makes perfect sense. It's intuitive. No? Yeah? Yes? Everybody's like, no, I have no idea what we've done. Right. So that's sort of the downside to this one. But we're done. That was a lot less writing. Yeah, I know. Like, how are we done? Well, we have to interpret this answer. We got to understand it. It's not hard, but we got to understand it. But like, that's a lot less writing than the other one, right? So anyway, so f at x equals, well, x plus 2. We know the divisor. That's easy. And then see how it started with x cubed, which will have 4 terms. Like, even if one of them is a 0, it's got 4 terms. And then this will always have 3. And so it's like x squared, x, and constant. So this is 1x squared minus 7x plus 13. Whoops. And the minus 14 at the end that I blocked off it off for a reason because it's the remainder. It's one of those things where this is like a trick. When you have done this a few times, and when we do the third example, compare it to the long division, and you'll see what we're doing is long division. We're just writing it in a different way. And so it's really bad practice to do something and have no idea like why you're doing it. So the fact that we learn long division, this is like just a shortcut version of that. It's a nice way to write it, but you still should know what long division is in order to give it context. Other? Yep. Okay. Gotcha. Sure. Okay. Yep. Okay, next one. Try to write it. Just write the first part, sorry. You don't have to do the whole thing. Again, look carefully what's happening here. What's happening? Anybody notice it? So I've got 2x to the 4th, 5x cubed, 0x squared, negative 7x, and positive 10. Okay, I'm going to get you started. The 2 comes down. And then what do? Mason? Right, so negative 2, so that's negative 4, and then subtract. Okay, so see if you can do a couple of steps of that. And then see if you can write the division statement. Don't forget you're subtracting. So 0 minus negative 18 is positive 18, right? You're adding. You kind of have to actively say it in your head. This minus this. Negative 7 minus negative 36 is positive 29, right? Like you really got to, or use your calculator. That would be an easy way to do it. Do you recognize it? And you get the same answer? So they both work. Very nice. And you can compare them if you want to kind of look at how they compare to each other. You recognize those numbers, don't you? Like it is the same process. Yeah. That wasn't by accident. Yeah. So this was 2x to the fourth. So now this is 2x cubed plus 9x squared plus 18x plus 29 plus 68. Yep. Okay. And again, if you think about it, take a look. What the whole point of this is that when I expand this, I get back to, so x times 2x cubed gives me 2x to the fourth, right? Like that had better happen. If it's not going to happen, then you've done something wrong. Any questions? We're going to do one more that's a little bit different. Everybody okay? Okay. So this is synthetic division still. And when I take a look at this, x to the fourth, third, second, first, constant. So I've got every term there, so there's no tricks there. Write out the coefficients. Why is this question different? Everybody take a look. Because of that. So when there's a coefficient that's not 1 in front of the x or in front of whatever you're dividing into, it changes things. Okay? So we still start by bringing down 2. The extra step is that I divide it by, sorry, should be the other way. Whoops. I divide it by that. Okay, so 2 divided by 2 is 1. And I go 1 times 1, which is 1. 7 minus 1 is 6. 6 divided by 2 is 3. Again, why are we dividing by 2? This. Like if this was a different number, we'd divide by that. If it was 3, we'd divide by 3. We don't always divide by 2. We're dividing by whatever that number is. Okay, 1 times 3 is 3. 13 minus 3 is 10. 10 divided by 2 is 5. 1 times 5 is 5. 25 minus 5 is 20. Divided by 2 is 10. 1 times 10 is 10. 10 minus 10 is 0. You wouldn't divide this part. It's 0, so if we divide it, wouldn't change anyway, but you wouldn't divide this part. You stop here. You don't divide the remainder. What does the remainder of 0 tell us? That it's a factor. Very good. So therefore, let's write our division statement. F at x equals 2x plus 1 times x cubed plus 3x squared plus 5x plus 10 plus 0. So it's kind of like we factored it. Now it's not factored fully, but we've started factoring it. We split it up into two. Both of those, in fact, are factors. Right? Remember when I said 24 could be written as 4 times 6, factors of 24. Or 4 times 2 times 3. Or 2 times 2 times 2 times 3 or whatever, right? Prime factors. So anyway. And we might say, and 2x plus 1 is a factor. Like there are times where you're asked to do the division and state whether or not it's a factor, so you would make that statement too. We weren't asked, I don't think, in this case, but that's how you would show that. Okay. Last little thing that you could think about is, again, 2x times x cubed gives me the original 2x to the 4. And 1 times 10 will give me the constant, which is 10. So if you're trying to think of, like, just is this answer right? You can look for those quick couple of little clues to make sure that what you have makes sense. It's not a bad idea to go back and check your answer.
So when you say like 2x plus 1 is a factor, you say is a factor of f of x?
Yeah, you could say it that way. Yeah. I think it's understood, and when we get into this a little bit more, it's kind of understood, but yeah, it is a factor of what we were dividing into, which is f of x. Yep. Any other questions? Okay, there's some practice to try.